The effects of misleading, explainable intelligent systems on user trust based on domain knowledge. Widely used machine learning systems, for example classification systems, are often referred to as black boxes because a complex methodology for how the results were created are left unexamined and unexplained. This results in a variety of trust-related issues for the user. For example, in a medical decision support system, having users over-rely on the system can cause false diagnosis, which oftentimes could be fatal for the patients. In this research, we study the effects of domain knowledge on the reported trust, perceived accuracy, and response time of a user, specifically in a machine learning system that generates inaccurate explanations. Previous work includes Busan et al., who conducted a user study that used medical systems to distinguish the positive impact explanations had on trust and reliance. Kiselek et al. Determined that highly detailed explanations could confuse the users and lead to their mistrust in the system. Yin et al. Showed user trust is significantly affected by the observed accuracy of a system. We created a survey and distributed it on Qualtrics. 18 participants in total completed the study. 9 entomologists, our expert group, and 9 novices. We recruited as experts graduate students from entomology at Texas A&M University and novices from the general graduate student population at the University of Florida. Participants used their personal computers to respond. Simulating an explainable image classifier, we showed a series of labeled images of arthropods, accompanied by an image with a highlighted explanation for the label. We did not tell our participants that the system is not a real system in order not to bias their responses. We asked a real entomologist to generate labels and explanations. We had her label some of the images wrong without changing the explanations. Additionally, the images could contain easy or hard arthropods based on user domain knowledge. We had a total of 40 images split into 8 groups of 5 images each. These groups were balanced so that they contained equal numbers of easy and hard, correct and incorrect images. Images were shown to participants in a random order. All these images were captured by our entomologists. After viewing every image, participants were asked if the explanations was appropriate and how confident they were that the label was correct. Once they had seen all 40 images, participants answered a short questionnaire about their perception of the system's accuracy and trust in the system and how it had changed over time. Preliminary analysis was done on the process data. The bar chart depicts the mean and standard deviation of the reported trust as stated by participants in the first trial versus the final trial. We can see entomologists began with a decreased trust and further lost trust, while the novice, on average, remained the same. It also shows how entomologists are more skeptical of the explainable system in the beginning, while novice users tend to trust the system more. The table on the left depicts the reported accuracy given by participants at the end of the test. On average, entomologists reported a substantially lower accuracy, with a mean reflecting the actual system accuracy. For the first hypothesis, we stated that the entomologists would believe that the system was less accurate. To test this hypothesis, we first ran the Shapiro-Wilk test for normality. Since the results were positive, we ran the students' t-test, which showed there was a significant difference between final reported accuracy between the expert and novice participants. Through our study, we found evidence in favor of our first hypothesis. We also hypothesized that entomologists would consider the system less trustworthy. To test this hypothesis, we similarly ran the Shapiro-Wilk test for normality. The results showed our data is not normally distributed. Therefore, we used the cumulative mixed model statistical test to test significance. The results showed that there was a significant difference between reported trust over time. Thus, our results found evidence to support our second hypothesis. For the third and final hypothesis, we stated that entomologists would take more time to complete the survey. The Shapiro-Wilk test showed that the data was drawn from a normal distribution, so we used the repeated measures ANOVA. This statistical test depicted that the response time between entomologist and novice was not significant. Therefore, our experiment could not find any evidence to support our third hypothesis. In conclusion, we have shown that individuals with domain knowledge are more likely to recognize when the system is flawed, which leads to their overall distrust. Also, their perception of system accuracy is closer to the actual system accuracy compared to novice users. This also could lead to mistrust. These findings can help the explainable AI system designers build better systems that would lead to better user understanding and therefore trust.